Okay, we're going to see how large the number a shall be so that this integral from a to infinity 1 over 1 plus x squared dx is less than 0.001. How can we do this? Remember two things whenever we are dealing with improper integral. Know our integrations and then believe in our limits. Let's do it. And I'm just going to write this down as a shorthand way. I'm not going to write down the actual limit, okay? First, we will find the antiderivative of 1 over 1 plus x squared. And what's the answer for that? Inverse tangent. So we know this is going to be the inverse tangent of x, and then it goes from a to infinity. So we can just write it down like this. We can do this once in a while, and then we know the formal ways to do this anyways, all right? Anyways, you're plugging infinity right here into x. So we're talking about the inverse tangent of infinity, and then we subtract, plug in the a value, so the inverse tangent of the a value, and then we want to make this less than 0.001. Okay? Well, what's this? What's the limit as x goes to infinity? Arctangent of x, right? That's what it means. This is going to be pi over 2, and then we just have the minus arctangent of a, and that's less than 0.001. And now how can I solve for a? We just have to continue with our algebra. So that's minus pi over 2 on both sides, minus pi over 2 right here. So that this right here will give us negative inverse tangent of a, and then this is going to be minus, and you do this on the calculator, the first number I got is this, okay? So as you can read out on my first line, that's the answer. And we have this subtract pi over 2, which is, don't forget to do this in radians, everything should be in radians. Negative 1.569796327. Okay? And then what do we do next? Well, we have negative arctangent. Let's divide both sides by negative 1. Divide both sides by negative 1. So the negative cancels. And then we have the inverse tangent a. And then because we divide by a negative number on both sides of the inequality, we switch it. So it has to be bigger than, and this just turned out to be positive, and we have positive 1.569796332. And now what? Well, this is the inverse tangent of some number a. To solve for a, we apply the regular tangent, right? We apply the regular tangent. And then you have to be careful with this kind of inequality. Yes, the tangent and inequality, the tangent and the inverse tangent, then cancel each other out, and we get a. But then the inverse tangent, both actually, the inverse tangent is increasing function, but it's not a big deal. The deal is the original tangent, it's an increasing function. So when you apply the original tangent on both sides of an inequality, the inequality stays the same. Okay? But then when you divide by a negative number, it's actually a decreasing function, right? It's like y is equal to negative x. It's a decreasing function. That's why you flip the inequality. Whenever you do something, apply a function on both sides of an inequality. Pay attention to what kind of function it is. If it's an increasing function, then it's going to be maintain the same inequality. And then, of course, when we're talking about tangent, we're talking about in between of negative pi over 2 and pi over 2. That's where we can get the inverse, okay? And then the last step is we just do the regular tangent of this number, and then I got it on the calculator for you guys, which is like 999.999 something. And then in the end, well, let me just write it out like 999.999 something. And then the answer in the back of the book says a should be 1000. So there's the answer. I guess they want the a to be whole number, so that's why they say 1000. That's all.